But normal people cannot do this type of analysis. It uses much deeply in mathematics. So if you want to use this type of analysis, firstly, you must be a mathematician. There are few situations in which we do cipher analysis. The first one is cipher text only attack. In this situation, you just know cipher text. You don't know any plain text. So this situation is most difficult for attacker. The second is known plain text attack. This means that the attacker can receive many ciphertext and the corresponding plain text, and they use the pairs to break the system. The third is the chosen plain text attack. In this situation, the attacker can chosen many plain text and let the legal user to encrypt this plain text and get the corresponding ciphertext. Although this situation is a little bit ideal, but theoretically, this is a very important situation. Another more ideal situation is chosen ciphertext attack. In this situation, the attacker can choose ciphertext and let the legal users to decipher the ciphertext, and so he can get the corresponding plain text. So the third and the fourth situation is very ideal because, as you know, in a practical environment, what can you choose if you are the attacker? The legal users don't want to cooperate with you as attacker. But it's very important in theory. And we much know that there is a very important assumption, Kirchhoff principle. When we use a crypto system, the most important thing is not protect the algorithm itself. We should protect the key, not the algorithm itself. In another word, the algorithm to encrypt and decrypt is known to anyone, including our enemy. But the enemy will not know the key that we are using. So at last, we return to the three concepts of evaluating the security of crypto system. So you can now understand a little bit. The first one, computational security. So we just repeat. In Caesar system, the system is not computational security. obviously, we just try every possible key from the 25 key, and we will break the system very quickly because there are so few possible keys. Especially we can use now the computer. It's very quickly. The second one is probable security. In a probable security environment, we must use some assumption, mathematical assumption. For example, we can assume that a very large integer can't be factored efficiently by anyone. If we based our reasoning on this non-factorable theorem, then we can prove the famous RSA is very safe. The last one is unconditional security. It's much more ideal and it's often in an environment that we must say the security for some special kind of situation. And this third one is not easy to understand. So we will not put much words on this one. Okay, this is the end of the chapter 1 introduction. If you have any question, just wait for the last 30 minutes in our today's class time. We can discuss and ask questions about that. Okay. Just have a 10 minutes break.